In this video, we'll look at question 33 from the 2016 exam. So an element X decays into an element Y, which is a half-life of double that of X. And at t equals 0, only the element X is present. And we are supposed to say which of these 5 graphs of the number of atoms of X and Y as a function of time could possibly describe this situation presented above. We'll try and go through them one by one, starting with E. Well, the problem in E is that we are told that at t equals 0, only the element X is supposed to be present. There's no Y. And in the graph, the blue line actually intersects the y-axis at a non-zero intercept, which indicates that there would be some atoms of the element Y present at that time. So E has to be wrong. The problem with D is a bit more subtle. We see that because the half-life of Y is double that of X, that means that Y is more stable than X. As time tends to infinity, there should be more of element Y than element X, just because X decays much faster than Y. And that isn't the case in D, and D must be wrong. In C, the issue is that as time tends to infinity, and as there are less and less elements X to decay and to supply new Ys, the element Y will definitely decay faster than it is created. But as we can see in this graph, the abundance of Y always increases, and that's wrong. B is much better in that respect. The general shape is quite reasonable, but the only issue is that the total number of elements X and Y combined can't increase. And if we look at this point here at the peak of Y, we see that the total number of elements, the value of the red and the blue combined, is bigger than the number of elements we started with. And that's impossible. Or more precisely, not the number of elements, but the number of atoms of the elements. Well, and so it follows that the only correct graph here is A. So A was the correct answer.